Alright, so this is Wiley number 7, and there were some like weird things that happened with this one. I got it, but okay, so we'll just do it. So yeah, you can see that, right? Again, I'll be posting these up in the Facebook page. So ethyl bromide, and methoxybenzene have nominal molecular weights displaying a significant peak at mass to charge ratio of 108. Regarding their molecular ions, what other features would allow the two compounds to be distinguished on the basis of their mass spectra. Alright, so I just draw this is ethyl bromine, right? Ethyl bromide. And here we have methoxybenzene. Alright, so there was some background information I just had to check. I won't write this one out. I didn't understand what they meant by nominal molecular weight. So I went to Wikipedia, the real versus nominal value, and it says in measurement, a nominal value exists in name only. It is assigned as a convenient designation other than calculated by data analysis or following usual rounding methods. The use of nominal values can be used based on the de facto standards or some technical standards. So, and I guess basically it means in technical standards, these two different molecules are defined by having a mass to charge ratio of 108, and the question is, how can we distinguish them? So these were kind of like fill in the blanks. So I'm just gonna show you the information that they were looking for, and then how I filled in the blanks. And one of the blanks didn't seem to make too much sense to me, so maybe someone can help. But all right, so it says ethyl bromide will have a significant blank for the 81 bromine isotope at blank. the ratio of the peak at mass divided by charge is blank for the lower mass divided by charge value and blank for the higher mass divided by charge value. Okay, blah, blah, blah. The ratio of the peak at mz blank, lower mass value, and blank, higher mass to ratio value will be approximately blank. The spectra will also show peaks at blank for the presence of carbon-13 isotope. Right, carbon-13 isotope, and then it says methoxybenzene will have a small peak blank for the 13C isotope. Alright, so there was some background information that I needed to look up before I could do this problem. Alright, so let's deal with ethyl bromide, right? So if we have the ethyl bromide, just the M value where the electron's been shot and it hasn't been fragmented. There's two isotopes of bromide, right? There's bromide 81. There's bromide 81, and that makes up 98% of all bromine molecules. And then there's bromine 79, which makes up 100%. These are just ratios to each other. So this molecule could have two mass to charge types. You could have a mass to charge of 110 with bromine being 81, with bromine 81, which I said was 98% of the population. Or you could have a mass to charge ratio of 108 with bromine 79, which is 100% with ratio. The ratio is 100%. Alright, so I used that information to answer the questions. So let me just look at what I wrote in Wiley really quick. Here it is. Okay, so, right, let's move this and this. Alright, so ethyl bromide will have a significant, it's an M plus 2 value, M plus 2. I'll explain that in a second. M plus 2 for the 81 bromine isotope at 110. The ratio of the peak at the lower one is 108, and the higher one is 110, will approximately be 1 to 1. The spectrum will also show peaks at, now they said, this made no sense to me, m plus 1 and m plus 2 for the presence of carbon-13 isotope. Methoxybenzene will have a significant peak at m plus 1 for the 13C isotope. Alright, so let me just explain what I just wrote there really quick. There was a little bit more background information we needed though, and that was about okay, so on page 436 of the Solomons and Fryal textbook, Solomons and Fryal textbook, they give us, okay, there's certain molecules that have a +1 peak, and those elements tend to be carbon, hydrogen, and nitrogen because of their isotopes carbon-13, hydrogen-2, nitrogen-15. And then there's ones that have an M +2, which tend to be oxygen, sulfur, bromine, and chlorine. This means that these isotopes have, the isotopes of these elements have 1 neutron, the isotopes of these elements have 2 neutrons. So with that information, that's why I said, it said, right, ethyl bromide will have a significant M plus 2 for the BR81. So BR81, regular bromine is 79, BR81 is +2 of 79. Isotope at 110. Right here when I said what would be the MZ, the MZ for the higher, for bromine 81, would be 110. And then at 110. So the ratio of the peak at mass divided by charge 108, right, which is the lower mass value, and 110, which is the higher mass value, will be approximately 1 to 1. So the higher mass value with bromine 81 of 110, the lower mass value of bromine 79 with 108, their ratios are 98 to 100, so that would be approximately 1 to 1, right? Now this is part, okay, the spectra will also show peaks at M plus 1 and M plus 2. Wiley's just probably wrong here because carbons are M plus 1, not M plus 2. And then this last part, I don't even know why. Methoxybenzene will have a small peak at M plus 1 for the 13 carbon isotope. I don't know if that's how, maybe that's the way you distinguish. I don't know how carbon can have an M plus 2. The table on page 435 of the textbook doesn't show, there's carbon 12 and there's carbon 13. There's no carbon 14. Maybe, I don't know. It doesn't make any sense to me. But anyway, those were the answers, and I'll post it up. I hope this one made sense to people who are, I hope it made sense, because that was kind of a whatever video. Alright, thanks.